Let's take a look at some examples of solving quadratic inequalities graphically. So here, as you can see, we have a graph of a parabola and a coordinate grid. And let's see. It says, based on the graph, find the set of all x values for which p of xy, those are just points. P of xy is just like each point on the graph, are on the graph, and y is less than or equal to 0. Enter your answer using interval notation. So we're solving this inequality. Y is less than or equal to 0. That's our inequality. So to do this, you basically examine points as follows, as an example. Imagine you grab a point from here, that point. It doesn't matter which point, just grab a point somewhere there, okay? What you observe is that here, the y coordinate is equal to positive 4. Remember, the inequality says is the y coordinate less than or equal to 0. So you see that here it's false, right? In other words, 4, is that less than or equal to 0? So that's no good. You can repeat this and you can grab some additional points. For example, you can grab this point here. Again, you're going to see that, for example, the y coordinate is 6. Is 6 less than or equal to 0? Well, clearly that's false. That's telling you that it doesn't matter which point you take beginning here and here, like which doesn't matter what point you take from that blue portion, that will not solve your inequality. It makes the inequality false. It doesn't matter, I've chosen only 2 points, but you can choose any point you want from there. And you're going to get the same thing, a false result. When that occurs, that usually tells you that the inequality is solved by the portions below the x-axis. When you see this where it says less than or equal to, where it says y is less than or equal to, right here, let me emphasize this, especially the equal to portion, okay? Let's study that next, where it says y is less than or equal to. Let's study the equal to portion. So grab these points right here, okay? The value of y at that point is equal to 0. Is 0 less than or equal to 0? That's true. You see that? Then grab like this point right here. What's the value of y at that point? Negative 2. Is that less than or equal to 0? Let me write that in the right way. Is negative 2 less than or equal to 0? That's true. Right? That checks. Grab some other point like this one. Again, I'm grabbing some sample point. Is negative 4 less than or equal to 0? That's also true. When you mark the solution, though, we talk about the interval from the x-axis. So you're using these y values to check, but when you actually shade, you shade up there along the x-axis. So it's as if you were shading this way, okay? Like that. So far, this is from negative infinity, comma, and then up to 0. Because the 0 is included, because y equals 0 is true, you put a bracket next to it. Infinity always parentheses. Then you got to pick this up on the other side. So here, take a look. At this value right there, y is equal to 0. Well, is 0 less than or equal to 0? That's the inequality check. That's true, right? Choose some other point, like this one. Or this point. For each of those, when you check the y, like this is 1, negative. Is that less than or equal to 0? That's true, right? Is negative 2 less than or equal to 0? That's true. So then you're going to shade along the x-axis this way. So that goes from 5, so bracket 5, comma, positive infinity. So for any value of x, if you look down to the graph itself, it's made true in the inequality. If you grab this value of x and you look down to the graph, you're going to have negative 3. Is that less than or equal to 0? That's true, you see? So for any value of x that you choose from the green shaded portion, you look down to the graph, the value of y is less than or equal to 0. So that tells you the following, that this inequality is solved by the following. You're going to put negative infinity, parentheses, comma, 0, bracket. You need to jump over the gap. So that's union, bracket, 5, comma, positive infinity. And then in the box, you would put negative infinity, same thing. 0, bracket, union, and then 5, comma, positive infinity. Infinity, always parentheses. So now let's look at this one. It says, based on the graph, find a set of all x values for which the point p, x, y are on the graph where y is less than or equal to 0. Enter your answer using interval notation. Remember, p, this is just a reference to each point on the graph where it says p, x, y, okay? And our inequality looks like this. We have to have that the y coordinate is less than or equal to 0. That's what this is saying. The y coordinate is less than or equal to 0. So you divide your work into pieces. Let's take a look. Remember, y is less than or equal to 0. I'm going to zoom in here and imagine I grab this point right here. at that point is y less than or equal to 0. That's what you're checking. Well, the value of y at that point is positive 1. So in other words, what you're saying is, let me erase that. It's saying, is 1 less than or equal to 0? That's false. Okay? Maybe grab one more point here. Take a look. Is 4 less than or equal to 0? That's false. See that? You're checking the inequality. But this point is a little different. Let me grab a different color right here. Okay? Because here the value of y is 0. Is here, right here. The value of y is 0. Where you cross the x-axis. So take a look. Is 0, in other words, less than or equal to 0? That's true. Okay? Then grab some other point like this one. Check the value of y at that point. Is negative 2 less than or equal to 0? That's true. Grab some other point somewhere like this. Is negative 4 less than or equal to 0? That's true. Do you see that? Go up here. What's the value of y at when x equals 5? The value of y is 0. Is 0 less than or equal to, again, 0? That's true. Okay? So you notice that for all values of x, as follows. For all values of x from here to here, over that red portion, for all values of x, the corresponding value of the y coordinate is less than or equal to 0. So when you enter your solution, here the solution would look like this. An interval notation would be 0. So that's the starting value of x right here. That's 0. Okay? Remember, at the origin, which is that point, the value of x is 0 and the value of y is also 0. This red 0, this is the x, comma, and you end at the 5 right here, see? So you put 0, comma 5, bracket. So for any value of x from this range of inputs, right here, let me zoom in. For any value of x from 0 to 5, if you look down at the graph, the y coordinate, which for example is negative 4 is less than or equal to 0 is true. So this is what you put in the box. So here is going to be the following. 0, comma 5. And that's it.